So now we would like to define the velocity and turbulence, which is another important element of the fluid container details. And here we go with the velocity and the turbulence. So velocity is the vector field that has got the magnitude as well as the directions. And velocity is the guiding path of the fluid. It will going to describe how and where the fluid will going to flow, and it also has got the vectors through which we could visualize the things. Let's go ahead and take a look at the definitions of the velocity. So the vector field that has both the direction and magnitude, and it also helps in pushing the values of the density, temperature, and the fuel. So that means that in case of the fluid simulations, if you switch off the velocity dynamic grid, and despite of the fact you have the density, temperature, and the fuel, nothing will going to work inside that, because your fluid will remain over there at the point where the emitter is located. To push the fluid into the other voxel values or inside the container, you're required to use the velocities. Okay, and of course fluids can visualize the directional arrows. That's true. We're going to take a look at that when we start doing our practical lessons inside the Maya. And now we have the turbulence. So it is again a kind of a disturbance inside the smooth flow of the fluids, and it creates a disturbances in the flow of the velocity, causing it to change the direction with respect to the frequency and speed. The smaller value of the frequency will going to disturb the flow in a bigger way. So that means the smoke, or you can say the smoke will going to get disturbed, and it will going to have a bigger waves, whereas in the case of the larger values of the frequency, the waves will going to get reduced. And how often they're going to repeat, it's the speed. If you have a higher value of the speed, so it means that the disturbance will also going to repeat frequently. Now let's take a look at the attribute of the velocity that is called the swirl, which is a very important attribute, and it will going to control the vortices or the billowingness inside the smoke. Okay, and we have the velocity scale XYZ. So we would like to put the value of the scale to the 1, 1, and 1. So it simply means that with respect to the container dimensions, so the velocity scale would going to be, we're going to handle the individual dimensions of the container. And we have the turbulence strength, of course, that we're going to control the overall amount of the turbulence. Lower values will less try to disturb the flow of the smoke, with the higher values will totally going to change the way the smoke is flowing. And we have the noise as well as the frequency and speed. So noise is the property with respect to the velocity. That means we have the randomness inside the voxel values of the velocities in the dynamic grid. And in case of the frequency and the speed, so it simply means that once you're using the turbulence, the frequency will going to decide how bigger the disturbance would be, and the speed will going to decide how often the disturbance will going to repeat itself. So as far as the velocity and turbulences are concerned, we are done with this section. Now I would like to take a pause over here, and I would like to move to the temperature attribute of the fluid container.